Welcome back, Math 20-2. So today we're looking at the quadratic equations and everything we learned so far about the formulas. We're applying them to real word problems. So here's the first one right here. It says, during high school football game, the height of a punt can be modeled by this equation. Okay, where t is the number of seconds that have elapsed, and ht is the number of meters above the ground. Now, looking at this, well, t would be 0. There's no minus t as soon as the ball's kicked. Punting means to kick it. It leaves and goes up. So there is no minus. It's always 0 until it goes something like that, or close to 0. It might be a little bit above the ground. So without using the graphing calculator, explain how the following can determine. So the maximum height of the ball. Well, what form is this in? This is in vertex form or standard form. That means I could find the maximum height of the ball. The maximum height of the ball is going to be my y value. This is negative, so my graph is going to look something like this. My maximum height is right here, the vertex, and the y value of that vertex, which is k. So the maximum height of the ball is going to be 12.25 meters. Okay, it's the k value. All right, because of that formula. It's so nice. It's already in the way that we want to see it. Now the second part here says the time it takes for the football to reach the maximum height. Well, if this is my maximum height, okay, this is my x value to the maximum height. My y is my maximum height because it says ht is the number of meters. It's my y value. Then this would be my x value, so 1.5. So it should take 1.5, and I believe it's in seconds. The time is done in seconds because that is my h value. My h value will give me my time. And almost always time is going to be on my x value. Almost always time is my x value. The next part says the height of the football above the ground as the punter makes contact. So we want to know the height of the football as the punter makes contact. Now this one's a little bit trickier. Well, when the punter makes contact, that is 0 seconds, because that's when it starts. So our t value will be 0. So let's try this out. So we want to know the height of the football, given the amount of time, when t is 0, because that's when we start. So we have -5, and I put in 0 for t, minus 1.5 squared plus 12.25. So it's there. Now I'm going to try and calculate this. I'm going to get -5 multiplied by 2.25, okay, and plus 12.25. All right. So -5 times 2.25 is going to end up giving me hold on, just quickly go. That should give me 10.5. Give me -11.25, so this gives me -11.25, so we get -11.25, and we plus 12.25, which will give me a total of 1. So we are 1 meter above the ground. So he kicks it at a distance of 1 meter above the ground. Okay? So the height of the football above the ground after 5 seconds, or 0.5 seconds, sorry. So how do I do that? All I have to do is we try and find the height. So ht is equal to, now my x value is 0.5. First was 0 because that's right when he makes contact. Next one is 0.5. So -5 multiplied by 0.5 minus 1.5 squared plus, and we have 12.25. Okay, because after x, 0.5 is elapsed. So that is going to be, this minus that is -1. -1 squared is 1. So 1 times 5 is -5 plus 12.25, which would give me a total of 7.25 meters. So it'll be 7.25 meters above the ground after 0.5 seconds. Next part says, use the features in the graphing calculator to sketch and answer the following. Okay, so first let's sketch and use the graphing calculator. So here this, we're going to put in my formula right there, which is, I'm going to have to use, remember, these t's as x's, so I'm going to go -5, bracket, multiplied by x minus 1.5, bracket, squared, and we plus 12.5. And make sure my window is good, and I'm going to graph it. Oh, well, I'm looking at this, it's very narrow, so I'm going to change my window. Well, my x min, there's no negative time, 0 is the smallest time, but I'm still going to put -1 so I can see it. X max is 10. Well, it looks like in 8 seconds it'll be down within 8. Okay, and y min, well, I'm going to put -2. And my y max, I'm going to put it up to 20. So now let's see this. Ah, there, that's a lot better. Now there's my graph. Because we noticed actually the max is 12, so I could have actually said from before, my y max could be 15, and it'll look even better. Look at that. That's what the graph's used. So now it says, sketch the graph. I have the graph sketched. Determine how many seconds to the nearest tenth. Determine how many seconds. Determine how many seconds to the nearest tenth the football is 10 meters above the ground. So we want to know when it is 10 meters above the ground. So for this, my y, we want to know when it's 10. And to do this, we're going to find my intercepts. So I'm going to go second, calculate, and I want my intercept. So let's see the first. Oh, there we go. How many seconds does it reach 10? Okay. I think nearest time is the football 10 meters above the ground. There's 2 times. We have one here. Oops. So at 7.9, so at 8 seconds, I'm going to say, to nearest 10. So 0.8 seconds. And the other time is, and it's 10 meters. Find my intersect. Go this way. Get close. I'm going to get 2.2 seconds and 2.2 seconds. So it's above the ground, 10 meters above the ground at 0.8 and 2.2 seconds. Okay? So basically all I did was I put in y2, I put 10. And then I calculated. Now part C says, the punt is caught by the opposing team and the football hits the ground. Okay? It's not caught, so it goes in the air and it hits the ground. Use the feature on the graphing calculator to determine how many seconds to the nearest hundredth it took the ball to hit the ground. So when it takes the ball to hit the ground, that is right here. That is right there. That's at 0. So we're going to have to calculate that. My 0. So we want left bound, right bound, and my guess is going to be right there. I get it takes 3.1 seconds, or to the nearest hundredth. So 3.08 seconds. So it's pretty much the same thing as what we were doing this whole time. Okay? Except now we're applying it to word problems. So I'll see you tomorrow as we tackle these questions together. Good luck.